Unit 7, Bonds, Lecture 2, Term Structure of Interest Rates, Part A. One of the most important components of the bond valuation process is interest rates or yields. Now we're going to look more closely at how these interest rates are determined, and we're going to recap something we did in economics. We know that the Reserve Bank is ultimately responsible for influencing the interest rates. The interest rate tools that they have at their disposal are the discount rate, which is the rate at which banks borrow from the Reserve Bank, open market operations, buying and selling of treasury securities by the Reserve Bank in the open market, and the bank's reserve requirements. So the Reserve Bank sets out a percentage that banks must retain as reserves internally. So by using all of these different interest rate tools, the Reserve Bank is able to increase or decrease interest rates at any point in time in the market. The term structure of interest rates, or the yield curve, relates the term to maturity to the yield to maturity for a sample of bonds. The yield curve can take on various shapes. It can either be flat, ascending, upward sloping, descending, or downward sloping, or it can be humped. The most common type of yield curve is the ascending yield curve, where you expect longer term maturities to have a higher yield than shorter term maturities. Now there are different theories or hypotheses on the shape of the yield curve. The expectation hypothesis, that can be used almost to explain any shape, but that says that any long-term interest rate simply represents the geometric average of current and future one-year interest rates. So it's just a geometric average. So if you're looking at interest rates going up, then long-term interest rates will be higher than shorter-term interest rates because the geometric average would be increasing. If interest rates are going down, then the long-term average will be lower than short-term averages because, again, you are averaging out the previous year's interest rates. There's the liquidity preference hypothesis. In other words, long-term securities should provide higher returns than shorter-term obligations because long-term obligations are less liquid than short-term obligations, so they should carry a premium. Then there's the segmented market hypothesis, and that really means that if you look at the bond market, then depending on the investor's preference, they may choose a particular segment of the market. So that may explain the humped yield curve. So there may be particular institutional investors who might prefer the medium-term bond market, and that may make the yields on that market higher. Okay. We're going to look now at spot and forward interest rates. The spot rate is the yield on a zero coupon bond. A zero coupon bond is a bond which pays no interest, or the interest on a loan beginning immediately, that is beginning today. The spot curve is a series of spot rates and can be used to discount the cash flows of a bond. The forward rate is an interest rate on a loan beginning sometime in the future. So for example, if you're given a 2-year forward rate 1 year from now as being 4%, what that means simply is that if you decide in 1 year's time to take out a 2-year loan, the interest you will be paying is 4%. The forward curve is a series of forward rates, each with the same time frame. The par curve is a sequence of yield to maturities in which each bond is priced at par. Now, when we learned about bonds in the previous unit, remember we learned that if the bond is priced at par, that means if the price is equal to the par or face value, then that means the yield to maturity equals the coupon. A par curve is obtained from a spot curve, and all bonds used to derive the par curve are assumed to have the same credit risk, pay coupons with the same frequency, they are in the same currency, they have the same level of liquidity, tax status, and annual yields. Now, up to this point, when we have valued a bond, we assume that we discount all the cash flows by one common yield, the yield to maturity or required rate of return. Similarly, we have calculated all yield measures, yield to maturity, yield to call, holding period yield, and so forth, as a single interest payment that would discount all cash flows to the current market price. And in doing so, we made two basic assumptions: that the bond was to be held to maturity, and that all cash flows would be reinvested at the yield to maturity and other relevant yields. However, we're now going to go forward and vary these assumptions. And we're going to vary these assumptions because they are unrealistic and is based on the assumption that the yield curve is flat, which it may not be. Now, we all know, based on our own personal experiences, for those of us who have home loans and car loans and personal loans, that interest rates change. Interest rates are influenced by market conditions in the economy. Inflation targeting influences it. So we have to be mindful that the interest rate environment is never constant. Now, we just learned that the interest rates for today or at a particular point in time are called spot and forward rates. And different maturities or different loans of different maturities have different interest rates. So it's inappropriate to discount all the cash flows we have at one single rate. And going forward, it becomes more appropriate to discount each cash flow given at a particular period at the correct spot rate. And this is done in order to calculate a more accurate price. Before we move on, we're going to introduce some notation. And the notation 1FN refers to the interest rate for a 1-year loan that will be made n years from now. So n can be either 0, which means it's an interest rate for a loan being made now, which is the same as a spot rate, or it can be 1, 2, 3, and so forth, and that's the 1-year forward rate for a loan that is going to be made n years from now. S subscript n is the n-year spot rate, and as I mentioned, S1 is the same as 1F0, that is the spot rate today. And you can calculate the n-year spot rate from forward rates using the formula below.